If you have wondered where your hybrid MPI and OpenMP application is spending its time, what resources it's consuming, and where its performance bottlenecks lie, then our tutorial on practical hybrid parallel application performance engineering may be useful for you. In this tutorial, we will present live demonstration of HPC performance evaluation tools that include Scorpy, the instrumentation toolkit that allows you to generate profile and trace data files. We use Scalaska to analyze these trace files and search for patterns of inefficient behavior and generate performance properties that can be stored in call path profiles. These call path profiles are then analyzed with Tau's Paraprov profile browser or the Cube profile browser. We also feature interactive trace visualization with Vampier in this tutorial. To give you an example of these tools, here is the Cube profile browser, where in the first pane, we see what kind of performance metric was collected. This shows you data from Scorpy and Scalaska, where we see metrics such as time, the number of visits, and performance properties such as wait at barrier, late in receiver. The late receiver bottleneck is a performance property that occurs when a send operation is blocked until the corresponding receive operation is called on the other process. And this pattern refers to the time spent waiting as a result of this situation. This is the time the process could be doing some useful work. And to see where this occurs in the source code, you can look at the call tree and follow the call path. It shows you the location of the bottleneck, and we can see in the third pane the system tree where it occurs on the machine. So you can expand a particular node and see which rank was involved with this performance property. We can also see the box plot and the system tree. Other tools such as Paraprov can show you the profile files. Here I am looking at a profile output. Let me unstack the bars and click on a color which represents a function. Here's the name of the function, and we can see how it performs on all the MPI ranks. If I click on the MPI barrier, I can see how much time was spent in MPI barrier. This is the 3D visualization provided by Paraprov, where I can see the MPI ranks along one dimension. I can see the names of functions along the other, and the height metric can represent the time spent in the function exclusively. I also have panes that allow me to crosshairs, which allow me to see which function is involved. Here I see a bar plot, and I can zoom in to a given location and see the thread that is involved. Here I can see that the loop in this function on rank 199 took 129 seconds. I can see the shape of the profile in 3 dimensions. This is the Paraprov profile browser. We will also demonstrate the Vampier Trace visualizer, which shows you exactly what each rank and thread were doing along a timeline. So we can zoom in to a given segment of a timeline and see what was going on in the application. So we see a wait and an MPI iSend operation over here. Here's another example where I can zoom into a section of the timeline and see exactly what each thread, each OpenMP thread was doing. If you are wondering how we instrument the codes, there are various ways to do that. Here is an example. I can build an application, say the NAS parallel benchmark, and instead of running it in the virtual machine like this, I can simply add now exec-d score p. And when this executes, I'll generate performance data. And analyze it in Paraprov or Cube. So I can see exactly how much time was, say, spent in MPI receive on rank 0, which is 2.4 seconds, or launch Vampier directly on the trace files. Thank you.